Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we're joined by guest Paul Stack, who has been everything from a product director to a infrastructure engineer and developer. And Paul is with us today. He's going to tell us about a rewrite he did on a massive login infrastructure, not logging, unless it is logging.
Logging.
Oh, well, that makes more sense then. I couldn't imagine how your login infrastructure had gotten so huge.
Great.
Okay, set it up for us then, Paul. So it's a login, not login.
So, firstly, thanks for having me on. I love talking about these types of topics because they're very fun. Now, like in this particular scenario, I was at a company. I'm not going to name the company name just because it was a bit of a tire fire, and like when I started like building out this piece of infrastructure, and we sort of underwent a massive shift within the organization. It was a huge .NET application. I really mean like it was an absolute massive .NET application. It was like 1.1 million lines of C# and .NET code. So, it's like a hell of a monolith. And we had a CTO came in, wanted to rip this project apart. Like, we wanted to go down to microservice-based architectures. We needed to have like self-service for each of the teams to be able to do the different pieces. I was actually a developer at that time. Sorry, go for it.
Well, so I got to bring it. So you had this giant monolith, and was the monolith itself a problem? Like, was the fact that you had a giant monolith a problem in and of itself?
In so many ways, like so many ways. It was like the entire story with regards to that is each team had their own branch in Subversion. Okay, back when Subversion was a thing. Okay,
I
actually,
remember
it wasn't even
Subversion.
that far back. Each team had their branch. Each team worked for 4 weeks in isolation from each other in their
Wow.
branch, and then the company had what was called merge week. Okay, so
God.
each team would draw straws to see who would merge their code first, and of course, the earlier you got in the week, the better because you had less conflicts. And as the week went on and more teams got in, it was more and more and more painful to get in there. So, efficiency was not, let's say, the best within that engineering org. So
I
we
hope
went
this
and
is like 2006, 2007.
it is.
Okay, yeah.
It's like even actually maybe even a little later than that. Not much later, but yes. And like so a new CTO came into the organization, and it was very much a case of he wanted to like look for efficiency, look for understanding of what was happening in the system, create that pane of glass to be able to see what was going in the system and the architecture. So like firstly, like we started breaking this system down. Okay, like we actually created a flow diagram. So we were able to understand like where pieces of time was lost and where all of the engineering overhead and QA overhead was actually spent. And we found that the cycle time was actually something in the region of about 8 weeks before a single line of code made its way into production. Right, which
Oh.
is not awful. Like, for large enterprise monoliths, that's not terrible. No,
I guess yeah. Back
In early 2000s,
in
too.
the
you
early
ask me now
aughts.
in 2025 if it would take 8 weeks for my code to get into production, I would probably rage quit. I'm not joking
Yeah.
here, right? Like it's definitely would not be the most ideal scenario, but it was very much a case of we needed to start breaking down that barrier, breaking down those silos to be able to do it. Now, this was right actually I think this was 2009 2010. It was just around like the advent of DevOps, right? Really around when that was starting to take over. Continuous delivery was starting to become a huge thing
Mhm.
from 2007 2008 onwards. And it was like, this was the new hotness, right? This was the new
Mm-hmm.
agile where you had to check a box and you're like, I does continuously deliver. I have like wasn't microservices back then, but I had like small services that were like a distributed
Service-oriented
system.
architecture.
So was exactly the word. You're exactly correct. And so we started heading towards this plan, and we started like pulling these pieces out. And we found that when we pulled these pieces out, there was not really like a huge amount of sort of observability back then. We tried a couple of tools, like off the shelf tools that became expensive, but we kind of found that we had this huge sort of like log footprint to try and understand what was going on. Now, back then it was, I don't know if you gents will remember this, but Logstash was super popular, right? Like Logstash was one of the best little tools, like little utility tools that was created, and you had different forwarders to do different pieces of information. So we went through like an advent of what we were doing here. The first thing is like we stood up an Elasticsearch cluster. Now, this was back before Elasticsearch was like as popular as it was now. I think it was in the 0.x sort of like release phase, right? So it was early. It was very early in Elasticsearch. There was no real Kibana or anything in the first couple of advents of this. You were actually getting the raw indexes, and you had to like query the indexes in JSON to be able to pull the information out. So it was like we just set up a Logstash forwarder on each box, and it just fired it straight to the Elasticsearch cluster. Now you can imagine, like it wasn't UDP, so we were actually doing TCP forwarding from each of the nodes into the Elasticsearch box, and when you fired that much data at Elasticsearch in one go, it was not coping with it very well, and we actually caused huge request queues in each of our nodes. So we actually brought down the application servers, like in the first advent of this. Now back to the drawing board. And the drawing board here was like, all right, so we got to figure out a way that we're going to do this. We're going to figure out a way to keep the system up, but that the logs have to keep adding. So we thought, you know what? Let's write this to disk. So we wrote the logs to disk, and we had something that was reading from disk and forwarding it on, and that kind of worked pretty well. Again, we were massively overwhelming Elasticsearch because it was just huge amounts of data. So it
Did you
grew
run into the
again.
problem where you ran the disk out of space and then your server went down and you couldn't log in
Exactly.
because
Exactly. It was just an
I remember these days.
absolute nightmare because like you didn't have like apps that were this was actually Windows, by the way. These were Windows forwarders. These were Windows 2000 and I want to say 2008, 2003 boxes originally, then 2008 I think it was after that. And they were like Windows machines. They didn't have a lot of like the ops tooling that you would have, right? Because ops is more synonymous with the Linux world, and you had a lot more
Yeah.
tooling and a lot more, log rotators and all these different types of systems that go there. So we had to go back and figure it out again. Kafka came up. Okay, we're like, let's put a middleman in the system. Let's forward the data to Kafka. Okay, let's just create this Kafka cluster, and let's have different topics in the Kafka cluster that would forward it to the specific like correct ingesters in Elasticsearch. Worked pretty well. Actually was quite a success at that point. We were like, okay, this is like actually like got some great stuff. We're able to like flood this Kafka cluster. Kafka was able to just tickle it through as it needed to. It was just running in the background and it did everything. Now we started then realizing, of course, that logs were not real time. Okay, because the
Mhm.
time that it took a log to get from the application written to disk, forwarded into Kafka, and then processed by Kafka into Elasticsearch and the Elasticsearch index was probably in the region of 5 to 10 minutes. Okay, so it wasn't. I mean, if you needed real time logs, you needed a different way anyway, right? Like
Right. I mean,
we
for the time, that was not bad because at this time, I'm pretty sure I would still have to log into the box on a lot of these systems where
absolutely,
you didn't
absolutely.
have log aggregations at all.
No, and like in Windows, you had the RDP, right? You had the remote desktop into some of these ones, which was even
Yes.
worse, like honestly. So it was very much a case of this. This actually did us for, I'm gonna say, like we kept this for maybe 3 or 4 months, maybe 5 months. So we started then seeing some issues with logs dropped. We started seeing areas of inactivity of what was going on, and we started thinking, okay, what do we do now? Okay, because we have this middleman. This middleman wasn't coping really well. It was firing the data through. We were just overwhelming Kafka.
Did
Kafka has the ability. Sorry, go for it.
I was going to ask at this point, did you guys try to just reduce the amount you were logging? Like, did you really need all this data?
That would have been way too sensible. Like, it was very much the era of more observability, more logs. The more the data that I have in there, it doesn't matter if I use it, I want it. And like we had a whole different problem with retention, right? Because log retention became its own thing. So we started thinking, right, what now do we do with this Kafka cluster? Now Kafka has the ability that Kafka can create, it can forward to itself. So you can use a Kafka output that forwards to another Kafka topic, right? So we were able to actually like effectively break down the Kafka cluster, where you had a centralized Kafka cluster and it forwarded it into other Kafka clusters, which then forwarded into like logs, Elasticsearch. So we fanned it out. Now at this stage,
Okay.
it was starting to get pretty large, right? Our Kafka cluster was starting to get overwhelming. It was kind of starting to get a bit painful. And what we actually started to do then is we started having like we brought a Kafka cluster closer to the each application's like stack. Okay, so like we had, instead of having one centralized Kafka cluster which took care of everything, we had actually smaller, tiny Kafka clusters which then sort of aggregated and forwarded in. So each
So I have to
sort of
ask.
app, go for it.
I'm visualizing in my head because I was there, but so that we're 2008, 2010. We're pre-cloud. So this is infrastructure that your company has probably rented in a data center somewhere, or multiple data
Yep,
centers
yep, that's
that
exactly
you
right.
guys also have to admin.
Yeah, that's exactly right. Like and I think now we're getting into probably 2010, right? So it was definitely like the early 2010s at this point, just because of the fact that we were actually using Kafka and we were actually like taking advantage of this. But it was very much a case of we brought a log collector. That log collector was Logstash. That forwarded it into Kafka. Kafka then forwarded it through to a central Kafka, which was like the final area, which triggered it into Elasticsearch. Now, the data that we were able to start passing through here was really pretty large. Now, we started finding patterns with Elasticsearch at that point, that we could start to be able to break down the Elasticsearch cluster. Like the way the Elasticsearch cluster would usually be is that you would have like a number of nodes that would form a quorum, right? So you could have 3, you could have 5, you could have 7, whatever you needed. And like a basic like Elasticsearch cluster back then was probably 3 to 5 nodes where you had a quorum of 2 or 3, right? So you needed each of the indexes to be available on each of those nodes before it created. Now, there was a pattern that was created in Elasticsearch back then where you could actually shard the master nodes and the data nodes. So you could actually like bring them apart and you could actually like have like a small cluster within Elasticsearch, which was the like the heart of the Elasticsearch cluster. And then you could just
Mm-hmm.
keep adding data nodes and data nodes. Think of it as like adding like SSD disks into like an array when you actually need into a RAID array when you actually needed it. And that's exactly what we started doing. So we created this like centralized login infrastructure where it was 3 nodes, and then we just kept churning out the size of the data nodes behind it. Now, we were probably in the region of about 20 to 30 million log requests an hour at that point, which was not a huge amount, right? It's really not a lot. Across all of the applications that we had, across all of the nodes in the application and the load balancers, it was not really a huge amount. So Elasticsearch was coping really well with this cluster. So we started throwing more data in and more data in and more data in. So and
More
then we
data.
started, I think this now took us like the next year, maybe a year of like building this infrastructure. And then as the system started getting bigger and growing out, we had a major outage. Absolute major outage. We lost our Elasticsearch cluster, okay, which meant we lost all of our logs. Like we were completely blind to the system. Like we had no idea what was going on. I remember that night vividly because I got paged. And I was like, oh no, like, so I had myself and my entire team, we were trying to figure out what was happening. We had like these backups. We were trying to restore from backup into Elasticsearch. But as soon as we brought the Elasticsearch cluster up, it was trying to rebalance the shards across it. And of course, because the Elasticsearch cluster was up, Kafka said, oh, I can start firing more data in. So we're trying to rebalance this cluster with an old backup of the data plus new data was coming in at the same time, and Elasticsearch was not happy. So we started actually, I think this was now 2012, because we were able to take advantage of some commodity hardware in AWS. So we started like experimenting with different instance sizes in AWS. So we had a private link, a VPN that went from our data center, our physical data center, into the cloud, and we stored all of our logging infrastructure in the cloud at that point. Now, this was where it got interesting. Okay, so
Okay,
we were
that's weird.
we were able to like we were able to
Before that,
restore
that was just set up.
that was just literally all set up, and we were able to like restore this and like to get it to the point of it was up and around, and then we started like thinking about retention patterns, right? How much data do we actually need in here? I think there was
Yeah.
something in the region of about 1.4 terabyte of logs in the cluster at that point, and exactly to your point, how much data do you need? Right? Like, how long do you need that data for? How useful is it? Like, at this point, I actually think I could go back in the logs an entire year. Okay. Now, nobody looks back in logs a year ago. Like, it's just not a thing, but it was a flex. And we go, we have all that data. We could show it. We could understand it. We could trend it. We actually had Elasticsearch indices that did different things. So we had an indices that was for long term. You could see the trends. Then we had one for medium term trend. And then you could see the short term sort of
Yeah, that's cool.
information, and we needed to grow this and grow this. So fast forward, it got to the point where we actually had 130 EC2 nodes, smaller nodes in the cluster. Okay. Now they were real commodity sized nodes, right? They were like 80 gig nodes. They were like pretty small nodes with like low level CPU. They were just like tiny, small throwaway machines, but we could just cluster these machines just as pure data. And the more like nodes that you pushed into the data pack in Elasticsearch, the more like data you could actually fire at Elasticsearch and you could understand it. But then that's when things like it started to settle, started to understand. Then we sort of broke it apart a little bit because we had this huge centralized like logging infrastructure that you couldn't really understand what was in it because everything was in it. So then we actually had to start pulling it apart. So it was an incredibly fun project. Now, all of this was pre Terraform. This was pre like infrastructure as code tools. I actually used Puppet for a bunch of this just because that was the flavor
That
of
was the best.
configuration management tool that we could actually use at the time. And it was incredibly powerful for what we could do, right? As soon as we put a new data node in, the data node would check in with the Puppet server, it would get its configuration, it would immediately get put into the Elasticsearch cluster. It like felt a really lovely sort of infrastructure. I believe at the end, it's been a long time since like I used to give a specific conference talk about this because like I could actually show the architecture patterns as we went through. But I believe we got to about 1.3 billion log lines a day was getting pushed through this infrastructure, which
Great.
was pretty intensive. And the system was like coping incredibly well. Cost was a major factor at the end. Like, I mean, you can imagine just how expensive this was. Like it
Yeah.
was growing ridiculously.
Well, so going back to the top though, so this logging system breakout was part of the CTO had come in and given a mandate to break apart a monolith so that the teams could operate more efficiently. And this logging infrastructure monolith evolved out of the back end of it. And, 1.5 billion lines of logging a day, there needed to be some, like, I assume this was a profitable company, or at least they had software that people were
It's a
using.
public company. Yeah, it was a
Yeah.
public company. Yeah. Yeah.
And yeah, so costs are now becoming a problem. Has the monolith been broken apart at all at this point? The other
Yeah,
people?
absolutely.
Oh,
Absolutely. Each team had broken their application out. They had gone to like different language stacks that they wanted. It wasn't just
dear
.NET
God.
anymore. There were people writing in Ruby. There were people, I actually believe there was like somebody wrote in such, I think one of the applications was written in Lua just because they could. Like one of the teams was like, oh, I really want to write something in Lua. It's like, all right, cool. Like, it was a case of creating the environment to allow the teams to experiment and be able to do the things that sort of like allowed them to be proactive and like productive to like the different pieces. And it
At
worked. It
least you
worked
don't have merge
incredibly well.
conflicts on merge week if
Say
everyone's
again, I'm sorry.
using. At least you don't have merge conflicts on merge week if everybody's
Absolutely.
using
Like, I
different
Yeah.
mean, each
languages.
team had moved to continuous delivery. They were in charge of their own like destiny, and it worked really well. And the reason it worked really well is because it sort of empowered each of the teams. Now, myself as the person who owned this centralized ops infrastructure, it was pretty cool because we had given people the ability that not only could they like be able to control their deployments, they could actually push their deployment markers through this. They could like push their CI/CD logs through this so they could understand what was going on. So it really did empower the teams to be able to break that down. But like when I talked to the CTO about this, like later, I think it was 2 or 3 years later that I left the company. I was leaving the company, and I asked him what his goal was here, and his goal was very clever, and he didn't tell me it at the start. He said, "You need to give people that space to be creative, to be able to do the job that they need to do. Then once you know that they're doing it at a high efficiency, then you can start to rein in the cost. You can understand patterns, you can understand like reusability, you can understand these pieces." So he's like, let people go, let them choose the physical data center, let them choose the cloud, then we standardize later once we actually have these patterns in place and the teams were working at full efficiency. And that's exactly what we did, or exactly what they did. So they were able to say, right, now we can cut it that you only keep a month of logs, right? They hugely decreased the cost of like that infrastructure, hugely decreased like the operational overhead of managing that infrastructure, because it went from 130 EC2 nodes to like 35 EC2 nodes. You know, straight away there was like way less operational complexity that went with it. They were able to reduce the amount of logs once they could understand what the system was doing, how the system was performing. Then they fine-tuned the amount of logs that were
Mm-hmm.
going in there, and they were able to like reduce the signal and reduce the noise and increase the signal for what they were actually doing. And like we still see this today, right? So it's actually incredibly funny that back then we were doing it in a specific way, but now you can use Datadog or you can use Honeycomb or any of these log sort of aggregation tools, or these OTel telemetry tools, and you do the same thing, right? You push so many like pieces of information in there. And after you push all that information in there, you have to think, right, do I need all that information? How much is that information costing me? I mean,
Mm-hmm.
I'm sure you definitely have listeners who have had their first bill from an hotel company, and they're like, whoa, like I did not expect it to be that expensive. Right. So what do you do then? You start looking at paring down what you send there. You only send the right amount of information.
Yeah.
You start to look at structured logs. You start to look at the information that you send there. So we've not really learned anything in 15 years, apart from the fact that there's a huge fire hose of data that at some point you have to cut that data, but it's now commodity to be able to do it, right? You can buy an off the shelf tool to do it rather than like having to home grow your own
Right.
infrastructure to be able to do this.
This
So it's
kind
a
of reminds
super
me of
interesting ecosystem.
This kind of reminds me of setting up like Sentry at a company for the first time and getting a flood of like exceptions that come in. Then you go through and go, okay, well, now I can fine tune how much exceptions I want thrown here, or I can go prioritize the exceptions and go ahead and reduce the noise here. But right now, all I care about is just getting all the data to see what I can do with it. And then we can kind of fine tune it like you're talking about. So a similar flow.
But it's hugely empowering, right? Because like if
Yeah.
you think I started in development over 20 years ago now. And if you think like over 20 years ago, we worked in probably companies who everything was so far segmented. You had ops teams and you had engineering teams. And like as an engineer, you didn't really have a huge level of visibility into what was going on. And the ops
Right.
teams didn't really have a huge visibility into what was going on in the software. So
Yeah.
there was like these two completely separate organizations within an organization that didn't have that sharing of information. So we're really in this ecosystem right now where like we have created this self-empowering ability that people can self-serve where they want, and it's hugely fun to be able to do and build like at such an early phase.
Yeah, I remember back in those days, I supported an app that it was a trading system, and it did the market data, and developers weren't allowed to touch the production boxes for security reasons. And one day there was a bug, and it took down the Japanese trading operations. And so I was on the phone with a ops person in Japan who was reading Java object stack traces to me over the phone, and I'm trying to visualize what he's telling me to find the problem, and it was brutal. It was also 2 a.m. uh, because of time zones.
Yeah,
So
but like and we still have this problem today. Like we
Yeah.
genuinely still have this problem today. Like there's sometimes in some orgs that haven't quite been able to move to this new way of working, this new way. Like let's think of um like physical data centers, or people who still have to use physical data centers, right? Who are not able to take advantage of the commodity in the cloud. Like if something goes wrong, in your data center, what have you got to do? Somebody's got to go and get in the car. They got to go down to the data center. They got to try and be that conduit of the information, what's going on. Or you have a remote hands in the data center who has to try and relay that information across
Yeah.
for you. And it's hard. It's really hard. Like, you know, what we're really starting to move and we're doing pretty well with it, but there's still teams that have to suffer this pain. And like I don't know, in 2025 that would be incredibly difficult to be able to feel like you're able to do, you know, the best thing that you can do for your users if you can't actually even see the logs that it's creating.
Mm, yeah. I think in
I
general, just
like
having
say again,
DevOps,
I'm sorry.
I think in general, just having DevOps more integrated into your team. Because I agree that like engineers don't know, or at least back then, don't know what the engineers don't know what the DevOps team is doing. DevOps knows how the system runs, but not exactly how customers use the application. And I still run into that every now and then talking to DevOps folks today, where they can say, "Oh, we know what's going wrong with the application. Here's the issue," and I'm like, "But they don't know what people use it for." And you're like, "What? Where? Why is there so this disconnect?" So I think that having more information and more communication around those engineers and DevOps, or just more. I guess people started doing like an embedded product person, an embedded DevOps person for the team to kind of have a faster feedback loop of that information. That's always been like a really great way to break that
Like
down, I think.
if we were doing this now, if I still worked in the company that was doing it now, and we had infrastructure as code that would do it, it would sort of allow you to. Firstly, I think it would allow you to be able to move a lot faster.
Hmm.
Okay, now, like, you know, back then, honestly, it was still like either VMware. We used a tool called Foreman. I don't know if any of you heard Foreman. It's like an open source project where you can either create virtualization based machines in a physical data center, or you could hook it up as a data source into AWS or whatever cloud you wanted. So Foreman like allowed us to be able to provision the nodes really fast. The node had to be like a specific type, so it had an exact footprint. So it
Mm.
allowed us to move in some way, shape, or form fast. It sort of took down the time taken for creating a machine from like a week to like a day. Like, you know, so you could spin up a node really like, and I mean, like a day's pretty great back then,
Oh
honestly.
yeah, yeah. I remember. I remember when Blades came out, and we all could get our own staging machine, our own machine in staging, because they were all now Blades. You get 250 machines inside a single one IC rack. I mean, I remember those days. They were because I think that's what I'm going. What striking me about the story is over like a 5 year period from about 2008 to 2013 or so, the industry it shifted from hopefully subversion, but a lot of no people running without source control to Git. It moved to the cloud. It added virtualization. It log aggregation became standard. Continuous delivery, continuous build pipelines became standard. Like that was a monumental shift.
And
That period.
it was like an incredibly fun time to be part of the industry, right? It was like I was I think that was probably when I realized that IT was actually kind of fun to be in. Like, 'cause my background is not IT. Like, I didn't like go to college for IT. I went to college for something completely different, and it was the most boring thing ever. So I decided to leave. But like, so you know, it was very much a case of that's when I realized that like you have to like really stay abreast of what's happening. You have to sort of have like an ear to the ground to understand the industry change and the industry like way it's
Mhm.
moving. Because if not, you're kind of like behind. But also, it kind of got dangerous because if you move too fast, the technologies that you adopted may not even be there in 6 months, right? And I
Right.
remember vividly within this organization where you had half of the organization using Puppet, and you had I'm going to call them a rogue sect of people within the organization who thought that Chef was the way forward because
Mm.
they didn't have to worry about a DSL. They could just break open Ruby and they could just write some Ruby. And like you know, at that point in the organization, you had to have that argument, which is the one that you have to standardize on. Like, where do we have to go? If you have to move from one to the other, how do you migrate the scripts from one to the other? And that's when, like, kind of the CTO was like, we're just going to let this shake out and we'll have all of those conversations later, because if we stop people from being productive and we stop people from like being able to deliver the systems that they need for the organization, then like it grinds to a halt for the user. And we got to move fast, because if you're not moving fast, a competitor will sweep in. They'll grab your users, they'll grab whatever, like, you know, the downstream consumers of the product. But there was a lot of difficult conversations to have after that, like a lot, you
Yeah.
know, and especially as you moved into the cloud, it became more and more difficult. You know, that was around the rise of Ansible. Ansible became incredibly popular, you know, after Puppet and Chef, where people were actually able to like, you know, write a bit more imperative style scripting with some like data sources that allowed them to be able to do some like pieces of information. So it was an incredibly fun time to be able to be part of the infrastructure. I mean, if I was to do that today, would I like take on that task? Would I build that infrastructure in that way? Absolutely not. Like part of it was naivety on my part. Part of it was like a bit of almost bravado of like, you know, I was like quite, I'm going to say I was young. I was relatively young, but not as young now.
Relatively young.
No, it was like, you know, it was very much a flex of I'm going
Yeah.
to work 20 hours in order to get this login infrastructure out. I'm going to like work my ass off in order to make sure it is. If I page the budget, then I'm going to give up everything that I'm doing in order to get it. Like, you know, you kind of get a little wiser as you get older and you realize that you don't really need to do those types of things anymore. But I think modern tooling would have definitely negated the need for what we had to do,
Hmm.
and we wouldn't have had to like have as much pain as we did. We would have had access to better dashboards. We not only Kibana, when Kibana came out as part of Elasticsearch, but Grafana has become synonymous in that ecosystem, right? So
Mm-hmm.
like Grafana being that sort of single pane of glass, not only across Elasticsearch, but
Yeah.
across your login metrics, your Prometheus metrics, all of these different pieces. So, you know, it's very much a case of you live and learn. Like you definitely hold these battle scars for some of the pieces of information that you've learned from some of these horrible projects. But like some of those projects back then were like super fun to do, like really super fun.
Nice. Awesome. Well, thank you for this story, Paul. This has been amazing.
Thanks for having me on. I mean, like it's been a while since I've reflected on this particular one. Like, and right now in System Initiative, we have. I'm not going to say we have the same makings. Like we're at like we're growing our application footprint, and
Mm-hmm.
because of that we're using Honeycomb. So the amount of like logs and the amount of like data points that are going into Honeycomb are actually there, so we can start to see them. And I'm starting to relive a little bit of the same thing about, okay, it's time
Nice.
to maybe pare
PTSD.
back some of the data that's in there. Maybe we don't need all of the data. Maybe we needed a different like levels of information, so you could actually be able to see it. So yeah, so thanks so much for having me on.
Yeah, thank you. If people want to get in touch with you or learn more about what you're up to these days, how would they do that?
So you can find me on, I still call it Twitter, I'm sorry, Stack72 on Twitter. I'm also on Blue Sky at stack72.dev. You can find me on LinkedIn at Stack72. You can find me on GitHub at Stack72, or you
Stack
can
72.
find us at systeminit.com.
I just want to know what was wrong with Stack 71 that you needed to
So
make a new
everybody's like,
one.
everybody's like, why Stack72? Is that year you were born? It's like, I know I look old, but that's not the reason why. Even though I live in the UK and I'm from Ireland, I played American football at university here. And my number, because I was a center, was number 72. And
Hmm.
I've carried that number with me the entire way from college across the whole way into my career. And it's just
Hmm.
kind of stuck. So
Yeah,
all
sounds
Sounds
of my
good.
good.
GitHub and like email and like all of these different pieces is all Stack 72. So yeah, so it's kind of like gone the whole way through from there.
Awesome.
Nice.
Thank you so much, Paul.
Thanks
I'm
for having
Jeffrey
me.
Sherman.
And I'm Isaac Askew, and this is Never Rewrite.